105.9 Academy FM.
The sound of Folkestone.
Hello, my name is Sophie. I'm from the Folkestone Academy. I'm going to interview Paul Thompson on the topic of space. It's going to be on various things, such as space travel and contacting aliens. What made you interested in space?
Very hard question. I've always been interested as far back as I can remember, but I guess one of the main things would have been the Apollo moon landings and the missions prior to the moon landings in the late 60s. I was about 9 when Neil Armstrong walked on the moon. So I think for me and a lot of people my age, it is the moonshot that initially fired up our inspiration. So you could go out on a clear night, look at the moon, and you suddenly realised we've been there. So I guess probably that was inspiration. But as far back as I can remember, I've always been fascinated with the night sky, looking up, the beauty up there, not knowing what's out there.
Kind of wish I could have seen the moon landing. Sort of nothing there.
But there's plenty of stuff on the internet. In fact, there's a new lunar probe at the moment which is going around taking very high resolution images of the landing sites. The new probe is now taking such high detail photographs you can see the trails of the footprints, the trails of the lunar rovers, the hardware they left there, the bottom part of the lunar lander. But the photographs of the lunar surface are superb. It's such high resolution images of the internal size of craters and the mountain ranges. Absolutely stunning.
Oh, that's actually really quite cool. Is there a particular thing that you like to look at through the telescope, like the moon or star constellations?
The funny thing is I really don't like the moon. Because the things I like to look at personally are what we call deep sky objects. These are things outside of our galaxy. Obviously, we have the moon and the planets and the sun. That's our solar system, so that's really quite local. But I like to look beyond our solar system to star clusters, nebulae, which are clouds in space, and then beyond our galaxy to external galaxies. So my primary area of interest is galaxies. I love looking at galaxies, the beautiful spirals. And when you look through a telescope and you see this very tiny little faint grey smudge, sometimes elliptical in shape, sometimes round, you have to realise that what you're looking at is perhaps 200,000 million stars in one little lump. Well, not little lump, it's a pretty big lump, but it's a very, very long way away. So galaxies are probably my main interest. But I'll look at star clusters and nebulae, clouds, they're lovely to look at. But I also like comets and shooting stars. Certain times of the year, any clear night, you look up and you're going to see at least one shooting star every 5 or 10 minutes. These are random, what are called sporadic shooting stars. Certain times of the year, we know that we're going to be encountering a stream of material that produces meteor showers. And over a period of a week or two, these showers progress in numbers till you reach a very short, sharp peak. And maybe half an hour in one evening, or one night, or one early morning, and you might see between sort of 30 and 200 shooting stars an hour. And in very rare cases, you can see up to, I think the record's about 40,000 shooting stars in an hour, which is pretty much constant, like almost snowing shooting stars. Astronomy is a massive, massive subject, and there's so many different things to look at. So you can't just say I like one thing in particular, because it's all fantastic. I don't like the moon because the things I like to look at get drowned out. So for 2 weeks of the month, the moon's in the sky. I can't see the galaxies and the clusters, not very well. So I wait till the moon's out of the way. But if I look at the moon through a telescope, I still go, wow, that is beautiful. It's just so much out there, and it changes all the time. Moon's always changing, planets are always changing. The planets have their own moons, they're always changing. Constellations change from month to month. Shooting stars come and go. Aurora borealis, noctilucent cloud, loads of stuff. So it's non-stop, always changing, and it keeps it exciting.
On your subject of the shooting stars, I actually looked through sort of my it's not a very good telescope, but I was actually looking at Mars, and whilst watching it, a shooting star went past.
That probably wasn't a shooting star, that was probably a satellite.
Oh, well, it looked like it.
Yeah, it will do. Very small speck, very, very fast. I mean, without being there, I can't say it wasn't. But more than likely, it would have been a satellite.
Oh,
because there's an
fair
awful lot of hardware out there. And quite often, a lot of our members do a lot of photography. and more often than not, their photographs will be interlaced with streaks from passing satellites. So quite often they're a bit of a pain, to be honest. But yeah, I mean, many times we've looked through telescopes at various objects, and you'll see a brief streak, which will be a satellite. I mean, sometimes they are shooting stars, but normally it's a piece of space hardware going over. Man-made rubbish.
I'm Sophie. I'm still with Paul from the South East Kent Astronomical Society. I would like to know, with various issues that have happened with like sending astronauts to the moon, like should we consider like sending men to Mars because of like various issues that could occur?
Oh yeah, we will do. Man, they will go to the planet Mars. They will do, yeah, without a doubt. Not sure when. It might be some of your colleagues here. Don't know. Might be your kids. It might be 30, 40, 50 years down the line. But man, we'll go to Mars for the same reason we went to the moon, because it's there. But there's danger inherent in any space flight, whether you're going into near Earth orbit or going to the moon or going to Mars. There's lots and lots of things to worry about. Spacecraft failure, eruptions from the sun, radiation, so many things. But like I said earlier, we're a naturally inquisitive race, and I think we must do it because we want to.
I think the cosmonauts are trying to get men to Mars, so I think they've been practicing it in their place that they do it.
They do, yeah. It's a Russian that holds a record for being in space. I think he was in space for, I think it was over a year, I believe. But it didn't do him any good, because obviously being in space, there's no pressure on your body. There's no gravity pulling you down, so your joints get weak, your bones lose calcium, so you become very, very weak. So obviously, from the research that the Russian cosmonauts have done and the research that NASA have done, they now sort of work together, along with the European Space Agency, and the Chinese are all coming online now. They're starting to learn that to do a deep space mission, to do a mission that's going to take a year in transit, you need to be concerning your bone structure, muscle structure. So you've got special exercises, special diets, special rigs that pull you down, elasticated straps, so you can run on a treadmill to keep your joints all working. So they are slowly but surely working their way to conquering long space missions.
When they do it, that'll be really interesting.
You watch this space, that'll happen. Might be sooner than you think. So
I'm interviewing Paul, who is an astronomer, and I'm intrigued to know whether, Paul, do you think that space exploration helps us understand more about our planet?
People just need to wake up on this planet and see what we're doing to it. I mean, we don't have to figure out how the universe works to figure out what's going on our planet, But I think we need to know what's going on in the universe, again, because of our natural inquisitiveness. I think we need to study the universe. We need to figure out, just for the sheer thirst for knowledge. It might make us better people if we understand our place in the universe. But what you have to realise is our place in the universe is so insignificant, it's unreal. If you look how big the Earth is compared to the Sun, it's a speck. And if you look at the Sun compared to Arcturus or some of the bigger stars, that's a speck. And if you look at those stars in our galaxy, there's 200 million stars in our galaxy, and there's 200 million galaxies in our locale. It's an infinitely large place, and our little spot that we have about our Sun is very, very insignificant. But I still think it's fantastic that living on this little tiny speck and being who we are, we still want to know, and we have the ability to learn what's out there. So yeah, I don't think it will change us anyway, but yes, I think we need to know.
So if theoretically we found some complex life, and should we contact them, or the possibility that they could theoretically still destroy our planet and everything we know, or go see some aliens?
Well, first of all, I think you watch far too much science fiction, but if we was to go ourselves, create a machine that could get us to the stars, we're not going to go there to wipe them out. We're going to go there to discover. So surely, if someone's going to traverse these immense distances across the stars, they're going to be friendly for starters. They're going to be wanting to find out where the noise is coming from their neck of the woods. If we could find intelligent life or complex life, then yes, of course we should. It depends what you call complex life. See, complex life could be a bunch of cells in one of these oceans under the moons of Jupiter. But if you're talking about intelligent life with the ability to communicate, then yeah, of course, if we could communicate, then we'd have to really. But yeah, of course we should.
Fair enough. Actually, you made a better point than what I was actually originally thinking when I came up with the question. So, like, on the idea of life and sort of intelligent or complex life, so do you think that there is some life that's not carbon-based?
I would have to say probably yes, because going back to what we said before, every galaxy has sort of hundreds of millions, if not billions of stars, and there's hundreds of millions or billions of galaxies. There's a thing called Drake's equation. Next time you've got a spare little while, go on the internet and type in Drake's equation, and it takes the smallest percentage of the smallest percentage of the smallest percentage, and it gives you a theoretical number of planets that would harbour intelligent life, contactable intelligent life, and it's still a very big number. But I mean, we can only draw on what we know, and we know carbon-based life forms like ourselves. But we have, we're limited by our own imagination. The universe is an, infinitely massive place. Lots of little corners, loads of space out there. Who knows what's forming out there? Who knows what's out there right now? Who knows what's looking at us? But there could be any sort of life form out there.